Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you can do remove, replace, reduce, and remove the 64. You'll have x squared plus 112x plus 3,136. And then when you replace and factor, you'll have 64x plus 56 times 64x plus 56. And then when you reduce, you'll have 8x plus 7 times 8x plus 7. Or you can write that as 8x plus 7 squared. From there, you looking at the math knowledge question, A to B is 3 to 1, and it says B to C is 1 to 5. So if I cross multiply, A equals 3B and C equals 5B. So I can replace that in this fraction here. Instead of A, I can say 3B, and then I have plus 3B over 4B plus, and instead of C, I can say 5B. So now it's all in terms of B. So 6B plus 3B is 9B, and then 4B plus 15B is 19B. And so your B's cancel, and so you have 9 over 19 for your answer. Okay, now we're going to look at lesson 42. We're going to look at the conic sections, we're going to look at circles, and then we're going to look at some constants in exponential functions. So hopefully after this lesson, you'll understand some about the conic sections, you'll understand about some circles and constants in your exponential functions. So a circular cone is the surface generated when you take a line where this point is fixed and then this point here is moved about in a circle. And if you rotated that line, it would create your cone. So you can do that with your pencil. Put it so that you hold one end and then tilt it, and if you make it rotate in a circle, it would be drawing out a cone. The cone is going to have two parts that are called napes that are on either side of the fixed point. So I made one circular cone when I made mine. However, if you take a longer line and you split it in half, when you rotate this one, this top part is also going to rotate. And so it would make two cones on top of each other, kind of like an hourglass, kind of, except for they come to a point right here. And so if the napes are cut by a plane, the figures that are formed are called your conic sections. So there are 4 conics, and we're just going to be looking at one of them today, but we're going to go over what the other 3 are. So if you take your plane perpendicular to the vertical axis, and it's only going to cut one nape, it's going to form a circle. If you tilt it slightly, then it forms an ellipse. And so this is a picture. Here are our 2 napes. When you have it perpendicular to your vertical axis, this is a circle that's formed right here. And then if you tilt it, this part right here forms an ellipse. So those are 2 conics. And then the other 2, one of them is a parabola. So if you tilt it further, it's going to make a parabola. And then if you tilt it so that it goes through both of your napes, is when it's going to be called a hyperbola. And this is what the picture of a parabola and a hyperbola would look like. So you've got to tilt it further to make it so that it does the parabola. And then if you tilt it so that it hits both of them, that's where your hyperbola is formed. So those are your 4 conics. We're going to look at those throughout the year, but today we're going to be looking at circles. So I do have in the classroom a cone that'll show you how to make your conics. So if y'all want to look at those, you can. They're foam. One of them's red, one's green, one's yellow, and one's blue. And they have it so that it's cut and you can pull it apart and see the 4 different conics that are formed. So if y'all want to pull those out, you can. They're in one of the cabinets somewhere. Okay, so we're going to look at circle today. Definition for circle, we went over in geometry, but it's the locus of all points in a plane that are equidistant from the point that's called the center. So standard form is x squared plus y squared equals r squared. And if you look at this triangle here, using Pythagorean theorem, x squared plus y squared does equal r squared. And that's true for any triangle that we form. I could put another triangle right here. My x value squared plus my y value squared would still equal my r squared. So no matter what triangle you draw, that form is always true. And to put it in general form, you're just going to set it equal to 0. So sometimes they'll give it to you in standard, sometimes they'll give it to you in general, and you'll have to put it in one or the other. Okay, so we are going to look at this first example where the center is at HK and the radius is R. And so this is when it's not centered at the origin. And so the formula is going to be x minus h squared plus y minus k squared equals r squared. So this is when your center is at HK and radius is r. So this is something that you want to write down and memorize. X minus h squared plus y minus k squared equals r squared. And you may remember that from geometry. We did go over it then, or you may have forgotten it. But you definitely want to know this formula. Okay, so now we're going to look for the standard form of the equation, whose radius is 4 and whose center is negative 3, 3. So our formula is x minus h squared plus y minus k squared equals r squared. So our h on this one is negative 3. So it's going to become x plus 3 squared, and then plus y minus 3 squared, and then equals, our radius is 4, so 4 squared is 16. So that is it in standard form. Then to put it in general form, you're going to have to distribute everything and set it equal to 0. So we're going to say x squared plus 6x plus 9 plus y squared minus 6y plus 9, and then minus 16 equals 0. And then if you combine your like terms, you'll have x squared plus 6x plus y squared minus 6y, and then plus 2 equals 0. So that would be putting it into general form. This one is going to be much easier to graph, and so typically whenever you're trying to graph them, you're going to want to put them in standard form. But that's how you do standard form or general form. Okay, so now we're going to move on to constants in our exponential functions. So remember, in exponential functions, the exponent has a variable, and the base is any positive number except for 1. So it can't be 0, but it's any number, just not 0 and 1, basically. Remember, that's what they look like if you graph them. They say the trick to graphing the ones that we're going to go over is to change it into a form that's more familiar. So I'm going to show you how to do that, but you don't have to do it this way. Okay, so we'll go over 2 different methods to graph these. So it wants us to sketch the graph of the function y equals 3 to the negative x. So that's the same thing as y equals 1/3 to the positive x. So you can change it to this form so that we don't have a negative in our exponent, or you can leave it like this. Either way, you're going to do an xy chart. And I'm going to pick -1, 0, and 1 to plug in. If you plug in -1 to either one of them, you're going to get 3. If you plug in 0, you're going to get 1, and if you plug in 1, you're going to get 1/3. So if you want to use this equation or this one, either way you're going to get the same points. But some people think that it's easier to plug in here. Some people think it's easier to plug in there. Personal preference, I don't care which way you do it. So you're just going to plot your points. And then there would be your graph. Let's try another one. So for this one, sketch the graph of the function y equals 1/2 to the 2x. So you can leave it like that, or you can simplify it like I'm about to show you. So 1/2 to the 2x is the same thing as 1/2 to the 2, all raised to the x. Because when we multiply those, you can put them together. So you can split them apart if you want. So it's the same thing as y equals 1/4 to the x. So if you want to plug into this equation or to this one, either way, you'll get the same thing. The book just thinks that simplifying it makes it easier to plug in. So I'm going to plug in -1. If I plug in -1, I'm going to get 4. If I plug in 0, I get 1. And if I plug in 1, I get 1/4. So when you graph it, you will graph your points. And then there's your answer. So it doesn't matter if you simplify your graph or not. Either way, you'll get the same thing. Okay, we're going to look at one more example. We want to sketch the graph here. So this is one that most students, when I show them how to simplify the equation, they say that's way too much work. I'm just going to plug it into that equation they give me. And that's fine. But some people get mixed up on the -x minus 2 part. So the first thing that you would do is to get rid of the negatives. And so you would do the reciprocal of 1/2, which would be 2, and then to the positive x plus 2. And then, if you have exponents that are being added together, that means that you can split them apart by making it 2 to the x times 2 to the 2, which is 2 to the x times 4. So this equation will give you the same answers as this one. So you can plug it into either one. I don't care. It does not matter to me. So if you plug in -1, 0, and 1, if you plug in -1, you're going to get you're going to get 2. If you plug in 0, you're going to get 4. And if you plug in 1, you're going to get 8. So if I graph those points, I've got part of my exponential, but I don't know what happens over here. So now I'm going to plug in -2. So if I plug in -2, I get 1. And then if I plug in -3, I'll get 1/2. And so there's your exponential. Now if you'll notice, this one didn't go through the point 0, 1. And the reason it didn't go through this point is because of that 4. So that 4 right there pushes it over so that it doesn't go through that point 0, 1 like all of our others. So you don't want to just go, oh, it looks like this, I think. You want to actually plug in numbers to make sure you have your points. So again, you can just plug into the equation they give you, or if you want to simplify it, you can. It does not matter to me. So your homework, you get to omit number 22 and number 28, and then you're going to have a trig quiz with your next lesson, lesson 43. It's going to be 5 minutes long, just like the last two. So make sure that y'all are continuing to study your unit circle.